Okay, we're going to try to get you a little familiar with the kind of primary features of a switchblade. So to start, opening and closing the arms are the simplest method, and that was the idea all along. Just keep in mind you rotate the propeller to keep it in line with the machine. Bring it back, done. Bring it back, done. The magnets on the arm retain it, and it's reasonably secure here. You can see, I wouldn't recommend carrying it this way, but you can see it's pretty robust. So, that begs the question, what is a good way to carry this? The intention was that the skids work as the carry handle. When they're open, right here was the idea. So you grab it, you've got good control over it, you can set it on the ground. It's also away from you. So in the event that there was ever some sort of a very unlikely event that a prop turned, you have the ability to get those rotating props away from you. So that's how you carry it when it's open. When it's closed, one of the #1 things I disliked about RC helicopters is you typically carry them by the main rotor, and they rotate around and they bang on things and it's a pain in the butt. So, when it's closed, make sure the props face you, and then put your hand around the rear skid leg, and when you carry it, you'll see it has a tendency to naturally fall away from your hand, so that when it's near your body when you're walking, it doesn't rub against you or make it difficult. Also, having the props face you while you carry it closed allows protection for the props so they don't catch on things while you're walking. Particularly handy if you're in a bushy environment or in the woods. So, next we want to talk about the payload deck. So go ahead and open it. Now the payload deck, I'm not sure if you can see from this angle very well, is vibration dampened. And it's got this ability to move independent of the rest of the system, and that's intentional. That's what these little rubber tubes are doing, is preventing, or they're isolating this mass from the vibrating mass. This helps give your video a nice clean shot, and you should note, these aren't clamped down all the way. The goal isn't to squish it tightly, it's to allow it to move. So, let's say we need to change it. We have another payload we want to carry, we have another deck, or we just need to access it. So I have another payload deck here, this one has a camera on it, and we're going to swap them out. It's not terribly difficult. You simply take the wing nuts off, and just lift it off. So now we have an empty payload deck, and we have a camera one. This also allows you access to the equipment. You will notice that the payload deck does not get in the way of using the USB interface. So there's a USB port right here on the left side of the APM unit. You're going to want to plug into that to do things like program missions, make tuning adjustments, etc. And it's intentionally got this big open area here so that with the payload deck on or off, you can simply reach in there with your USB cord and plug it in. On these rubber dampeners, there should be a larger hole on one side than the other. You want that large hole to face down so that it doesn't grip on the shaft. Doesn't make too much of a difference, but can help a little bit. Now, the payload deck wasn't designed to carry the stresses of carrying it around, so it is strong enough that you can pick the whole craft up by the payload deck and move it around. But it wasn't really intended to do that, with one exception. This logo that's toward the back of the payload deck isn't just for aesthetics. It actually serves a functional purpose, and that is, this is the ideal balance point for the center of mass. It's equidistant from each rotor. If you were to take a tape measure, you could measure a circle all the way around. It's the center point of the craft. So when you're ready to fly, and you've got your payload, you can grab the payload deck right by the center line of that icon, and then lift it up. If it's well balanced, it should be level. And as you can see, it's tipping forward slightly, and that's because it was balanced for a payload deck with no camera on it. So that camera's kind of teeter-tottering it forward here. So, we'll fix that. To fix it, flip the unit over, put it on its back, and we will adjust the position of the battery to accommodate whatever payload you're carrying. I find the battery comes off best if you kind of peel it off. And you can see there's a big section of space here that allows the battery to be put fore and aft to get your balance. So we were about here before. It doesn't take a whole lot because it was pretty close to level. So we'll bring it a little bit further back. Clamp the Velcro in there and give it a good tug on the tie-down strap here. Then we'll flip it back over. And we'll check it again. There we go, nice and level. That's what you want to see. It doesn't have to be perfect. It can actually be quite a bit out of balance and it'll still fly okay. But what will happen is if it's very aft balanced, you'll overwork your tail motor. It'll have to do a lot more work to keep the craft level. And if it's way forward, you'll be overworking your front motors. So it'll still work, but balanced is best. Okay, there's just a couple more things we want to talk about, and that is props and battery changes. The props are balanced. There's a small, not sure if you can see it in the shot there, but there's a small piece of tape on the underside of the propeller. It's just essentially a high quality Scotch tape, and that's used to balance the prop. And we do this because balanced props produce less vibration, and less vibration is good for everything. The flight controller will operate more efficiently, your camera will get a steadier shot, a vibration-free helicopter is a better helicopter. So, if by some chance you have a prop strike, or you hit the ground and you chip a little bit off, or you scrape a little bit off, your props may get out of balance. And if they get out of balance, the vibration may become so much that the payload deck isolation system can no longer fully isolate the vibrations from your camera. If that happens, it's likely the machine will still fly well, it'll still do its job, but your camera video shot may get what they call a jello effect, which is kind of a wave that runs across the screen as the harmonics of the vibration interfere with the video. If this happens, it's not a terribly big deal. It's not terribly uncommon either. You just take the prop off. You can buy a cheap little balancer from a hobby shop, or you'll probably make them available online here soon, and rebalance your prop, which is some Scotch tape. If the props get bad enough, you may have to replace them, but they're not terribly expensive. So that's beware of the prop balance. Lastly is how to change a battery. So we know now about how the balance point of the battery must be maintained to make it level, but there are a couple little details about how to actually change the battery. So it's hot swappable, so if you're in the field and your battery runs low and you land, you can change out for a fresh one and fly immediately. You don't have to wait. It could fly indefinitely. I've flown dozens of packs back to back without any trouble. So there's two connections. We connect the balance leads to the low voltage buzzer, and you can see this pack happens to be full, so all 5 lights are green. In the case of a standard SwitchBlade, there would be 4 because it's a 4-cell battery. And when we go to disconnect it, you'll notice if the props, or if the arms are closed, it's kind of difficult to get to the connectors. That was intentional because you should never be in this situation. You should never have a plugged-in pack and closed arms. Because if by some chance something went wrong and it got armed and these rotated, they'll tear each other apart. So you don't want to do this. So with the arms open, it exposes the connectors and allows you to get to them. And we simply unconnect the primary lead by holding the 2 pieces of yellow plastic here. You do not want to do this. If you pull on the wires, you're going to fatigue the solder joints and could cause a situation where it looks like it's working, but then it loses connection mid-flight, something you very much want to avoid. So we'll grab the plastic, pull those apart, and then we'll disconnect the balance leads from the buzzer here. Then once that's done, flip the whole unit over onto its back, undo the strap, and then kind of peel away the battery. And that's all there is to it. On my own personal unit, I have started to make marks with a Sharpie on the battery plate and the battery pack for different loads so that I can remember where to put it. So, for instance, if I'm carrying a GoPro Hero 3 like I am in this video, I would take a silver mark and then write GoPro on the battery and a silver mark here. So that if I change from, say, a GoPro to a heavier camera, I know where to position the battery, so I don't have to do that logo balance check every single time. So anyway, peel the battery off, get a new battery. Put the battery on, kind of squish it into that foam Velcro. Tighten the battery strap, nice and snug. Make sure that Velcro is really hooked on there. You don't want your battery coming off in flight. Flip the unit back over. Plug in the balance leads. Black is up. And if, in case you forget, there is a little minus symbol at the very top, and black is ground or minus. So we'll plug that in. And you'll hear it beep, and you'll see it go from red to green, which tells you that all the cells are at a good voltage. One little trick I found, sometimes when you're in a crowded area, that beeper can be kind of annoying. So if you put your finger over the buzzers, you can kind of mute it so it doesn't make that annoying noise if you're in a crowded environment. Then make sure your radio's on. Okay. So I got my radio on. You always want to have the radio on before this is on. And then just plug in the primary wires. Make sure when you're plugging in the primary wire that you don't move the craft whatsoever. It should be on a nice, steady, level surface. You should plug it in and then not touch it for about 10 seconds. That noise is the motors initializing. And then you might not be able to see it through the acrylic from that shot, but there is a series of lights on the APM controller that will flash back and forth. Once those settle down and there's a steady blinking light, usually takes about 8-10 seconds, something like that, now you're ready to be armed and everything's good. And what's happening here is, as it gets powered up, the computer's running through a series of checks and telling it where all the defaults are. So this is now the launch location by GPS. And it knows where level is. That's why it's got to be level and steady. If you happen to be moving it, or you jostle it a little bit while it's doing this, you may find some erratic flight behavior. If that happens, land right away and unplug the battery, wait about 10 seconds, plug it back in and leave it alone. Once it's initialized, you should be good to fly.